All right, at last we have arrived at the graphing problem. Due to the length of time it takes and the level of difficulty, I never do more than one in the class anyway, so I'm going to do this one. I usually do a similar one. This one's going to be a roller coaster. This one matches up to the one that you would have to draw. I'm going to run through the steps and I'm going to do the whole problem, and then I'm going to write you an outline of what you do when I'm completely done with it. The first thing you want to do, actually, is the easiest thing to do. I'm going to get a point for free. All I have to do is plug in 0 for x, and that tells me the y-intercept. So I'm going to take f of 0, 0 to the third, 0 times 0 times 0 is 3! So you got a free point for nothing. Now, you want to figure out where it's going up and down, increasing, decreasing. You want to find the maximus, the maximum, and the minimum. You want to find where it's concave up and down. You want to find the inflection points, if there's any, and then you want to try to make a picture. So running through it one at a time, first derivative, second derivative, and then blah, blah, blah. So let me do the first derivative, set it equal to 0. It's 3x squared minus 12x. You'll see, this takes a long time for me to do. I mean, I can't do it super fast. Right? Multiply, subtract, 12x, set equal to 0. I can factor out a 3x in common. So I get x equals 0, x equals 4. This part I'm going to skip a little to save some time. I'm going to put the number line. Once I draw the number line, I mean, this is like ridiculous to write all this. It takes time and I wouldn't be talking anyway. I put 0 and 4 on the number line. I'm going to underline them. Remember, you actually have to write intervals. You have to write the intervals where it's going up and down and where it's concave up and down. So I picked my test points. I need a number less than 0. I need a number between 0 and 4. Yeah, you can pick 2. Hell, you can pick 1.25 if you want. I don't give a damn, but you have to pick a number between 0 and 4. 1's easy. And I need to pick a number greater than 4, so I picked 5. Now remember what I have said over the last 2 lessons. I don't care what the value of the number is. I care about whether it's positive or negative. I care about the sign. So when I plug negative 1 into this, 3 times negative 1 is negative. Negative 1 minus 4 is negative. That gives me a positive. So I put a big ass plus here. It means graph's going up. I plug 1 in. 3 times 1, positive 3. 1 take away 4 is negative 3. That's a negative number. So the graph's going up and then coming back down. Plug in 5. 3 times 5 is plus. 5 minus 4 is plus. It's 1. So I get a positive. Come on. Plus. So this graph goes up, down, up. So it goes up and down. There's a high point. It goes down and then up. There's a low point. Now, I got to write the intervals, and I got to plug those in. Now, I have no room, so I'm going to erase all this and do that step. All right, so I've neatened things up here a little, very little. And I rewrote my number line with my signs. Increasing here, increasing here. So it's increasing from negative infinity to 0 and then 4 to infinity. That's where the graph's going up. The graph only comes down between 0 and 4. So I know that the graph went up and came down, so I know I had a high point here. Now, conveniently, I already plugged in 0 before. That happens to be my y-intercept. Yay, I got a free point. That happens to be my max. Now remember, wait a minute, 4 is bigger than 0, so this should be the max. This is not how it works, right? The graph went up and came down. I'm looking for the maximum y value. This 10 is the biggest y value. When I plug in 4, I'm going to get the minimum y value. So I'm going to do it. It's boring to watch me do it, so all of a sudden it'll just appear. Poof. Like I said. All right, so I plug in 4, get 4 cubed, which is 64. I'm pretty sure that 4 squared is 16, and I'm pretty sure that 6 times 16 is 96. And no, I didn't cheat, and no, I didn't use a calculator. I did it in my head, and I'm assuming I did it right. I might have did it wrong. Plus 10. So that's negative 32. When you add 10, you get negative 22. I'm pretty sure that number's right. So now, this is kind of obnoxious to try to graph this. You are not, I'll show you when I make the picture. You're going to cheat this. I'm not actually going to go 22 tick marks down the thing. I'll show you how to make it look pretty and cheat. Okay, so that's all first derivative. Increasing, decreasing, max and min, done. Now all I have to do is find the shape of the curve, right? Concavity, concave up, concave down, possible inflection point, and then I'm done. Once I know that info, I can actually start to draw this. I already know that it's going to go up, down, up. I just have to make sure I have the shape right, and I have the inflection point plotted. Okay, so I wrote the first derivative again, so I don't have to look back. And now I'm going to take the second derivative. It's going to be 6x minus 12, right? Multiplied by the power of subtract 1. Derivative of 12x is 12. And there's a negative there, so it stays. Now I have to set this equal to 0. Well, listen. Bring the 12 over there. Don't factor. You don't need to factor. Let's try to do this quicker. Second derivative, set it equal to 0. Solve it. I got 2. Put that on the number line. Yay, I only got 1 point. Easy peasy. Pick a number out here as a test point. Well, how about 0? Why not 1? You can pick 1. Who cares? I'm picking 0. You pick negative 1. Doesn't matter. Look, when you plug in 0 for x, you get 6 times 0, which is 0. Take away 12. It's negative. 6 times 3 is 18. Take away 12. Positive. If you had plugged in 1, 6 times 1 is 6. 6 minus 12, negative. If you had plugged in negative 1, that's negative 6, take away 12, negative. Any number that you pick to the left of 2 is going to give you a negative when you plug it into the second derivative. That's the whole game. So this was sad face. This is happy face. Concave down, concave up. So I do have an inflection point. You don't always have one. Sometimes the graph doesn't change. A parabola is concave up or down forever. It doesn't change from concave up to down. This graph goes from concave down to concave up. So I'm going to put that together with the increasing, decreasing in a minute, and I'm going to make the sketch and see how it looks. All right, now I said I was going to sketch it in a minute. Before I do that, I need this point. So again, concave up from 2 to infinity. Concave down, right, negative, concave down from negative infinity to 2. If it helps you and you need to, put the endpoints there. If you have trouble making the intervals, remember, you don't go to the test point. It's not concave down from negative infinity to 0. There's a lot of numbers between 0 and 2. You have to go all the way to 2. Now, I'm going to plug it in real quick. So let's see. I need to figure out the y value for the inflection point. So when I plug 2 into there, I get 8. You'll see me screw this up live. 2 squared is 4. 4 times 6 is 24. And then I need to add 10. So it's just 18, take away 24, right, which is negative 6. Now I have everything. I know where the graph is going up and down. I know where I hit a high point, and I know where I hit a low point. I know where I switch concavity. I'm going to plot these 3 points. I already underlined that one. I'm going to plot those 3 points. And then I'm going to play connect the dots using the increasing and decreasing. And I'm going to make sure I connect them with the proper shape. Okay? You'll see. It's going to come together quite nice. I'm lying. It's going to be a total disaster. I'll have to do it probably 20 times and keep erasing it. But you'll see a pretty picture. All right. Now for the moment of truth. This is going to be the hard part. This is always the hard part. I have to try to put all this information together and make a shape. So look, first of all, you need points to plot. I'm going to put 10, let's see, 22 is like twice that, right? So let's say I'm going to put 10 here. So I'm going to draw that dot. Well, let's call that 10. I need to do negative 22, so, you know, let's put it down here. Now, you're going to think that this is ridiculous, but I am going to make the tick marks on the x-axis. Trust me. I should probably spread them. Actually, I'm going to spread them out even further. I'm going to fix this and draw it again. I want to really, if I don't exaggerate this, you're not going to see the change in the curve well. So that's why I did that. Okay, so at 2, I'm going to be at negative 6. So let's pretend that's around there. Make a bigger dot. So that's around negative 6. And I'm calling this negative 22. So I have to go all the way over here. And somewhere over there. Again, this is not the part that's important. You'll see. All right, but you see, if I had the x-axis scrunched together, you're not going to see the differences in the shape of the curve. That's very important. Now, I know my graph goes up, down, up. This is gonna go real quick from here. I know that my graph to the left of 0 was going up. I also know that it's concave down till it reaches here. So I want you to think sad face, right? Sad face. That's concave down. Remember, concave up and down has nothing to do with the graph going up and down. It is the shape. So this graph is going to go up. Now I'm going to draw it this way, so it's easier to see. This graph goes up, 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 boom. Hits the max of 10. Now it's going to start to fall all the way down to that dot. But the problem is it doesn't go to that dot as a straight line, and it doesn't go to that dot concave down. It starts concave down on the way there. So you hit a high point. Your graph has to start falling. As it falls, it is still a sad face. Okay? So I want you to think parabola. It's still a sad face. So it's going to go wee, concave down. You see? Sad face. So graph went up, concave down. Graph went down, concave down. Now, boom. What did you hit? Inflection point. As soon as you reach this dot, first of all, the graph is continuing to fall. I have to reach this dot down there. The graph is going down, but now it's going to go down and be a happy face. So it's going to switch to concave up as it goes down. You see how it's a different shape when it hits there? Look, I'm drawing this as good as I can. You see now it's like a bowl. It's like half a smiley face. And now when it hits this point, this is your min. This graph is going to go back up, and it's going to stay concave up forever and ever. It's going to stay as a happy face. So keep it as a happy face, and it goes back up forever and ever. So concave down, concave up. See? Inflection point. To the left of 2, concave down shape. See sad face? To the right of 2, happy face. Concave up. The graph went up, down, 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 up. And that matches. The graph was going up until it hit 0. When it hit 0, it started to go down all the way till it got to 4. Down, 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 down. And then it goes back up forever. And it's concave up forever. All right? So concave down, concave up. Increasing, decreasing, increasing. So this is how you make the picture. I did the best I could. Most of you will draw it way better than me. But this is the idea. Now, I know what you're thinking. There's no fucking way that I can draw this. This is impossible. I'm getting this wrong. This question's worth 10 points. This picture I drew is worth 1 point out of 10. Why? Look at all this shit you did. First derivative, set it equal to 0. You got increasing, decreasing, max and min. Second derivative, set it equal to 0. Got concave up and down, inflection point. All of that work is worth 9 points. This picture is worth 1. You don't even have to draw the damn picture if you don't want. You still get 9 out of 10. If you did all this work right and you were like, screw this crap, I'm not drawing it. Then don't draw it. Who cares? You lose 1 point. The picture is not the important part. All this stuff you did to get here, all that work is worth 90% of the points. 9 out of 10. So don't freak out if you have trouble taking all this crap and translating into a picture. This is quite complex going from here to here. I mean, it's not that bad. You draw the dots you have, and you got to connect them using that information. But I know a lot of people struggle with this. I don't want you to stress out about the graph. Can't draw the graph. It's not the end of the world. I look at all this work anyway. This is how I grade it. You know, this is worth 2 points. This is worth 1. This is how it goes. Everything you did there is worth points. Took the derivative right, 1 point. Took the second derivative right, 1 point. All that stuff can give you points, okay? So don't freak out. I know it's complex. I know it's hard. I know it's long, time-consuming, pain in the ass, but it is what it is, okay? And this finally ends the graphing lesson. 3 videos on one topic.